Hello. So this is a question from JEE Mains 2026 28 Jan morning. Method used for separation of mixture of products B and C obtained in the following reaction is. So we have a reaction which is given to us, benzene ring plus bromine, and so we'll look into this reaction in a while, but we should know that the methods of separation that they have given us in the options. So they've given us simple distillation, sublimation, fractional distillation, and steam distillation. So we should know about these separation techniques or separation methods, and when are they employed or when are they used. Okay, so the first one is simple distillation. So distillation involves conversion of liquid into vapors by heating, and then we do condensation of those vapors by cooling. Okay, so in the case of distillation, it involves, so let us say A is for simple distillation, so it involves conversion of liquid into vapors by heating, followed by condensation of vapors by cooling. So this is what we do. Okay, so when we look in the diagram of simple distillation, this is the diagram for simple distillation. So what we do is we take a mixture of the two liquids, and obviously we have to make sure that their boiling point has a huge gap in the case of simple distillation. So let us say we have A and B for simple distillation. Let's say A's boiling point is randomly, let's take 150 degrees Celsius, and B is some 250 degrees Celsius. So you can see A is more volatile, that is it has less BP, so it can easily become vapor, so it is more volatile. So when we take this mixture of A and B in this tube, and when we are heating it, what will happen, since A has a lower boiling point, it will quickly, or it will become vapors, and those vapors, when they are passed through the condenser which contains water, cold water, what will the cold water do? It will condense these vapors into liquid, and we will collect A in this test tube, and here we are left with B. So hence we did the separation, right? So the only thing that we have to be careful, okay, that is simple distillation is used for separation and purification of a mixture of two or more miscible organic liquid, provided their boiling point difference is is a good amount. There is a good amount of difference between them, at least by 30 or 50 Kelvin. So that's the point that I will write down, that boiling point of mixtures should differ by 30 to 50 Kelvin. Okay, so this is the catch here. The next separation technique that they have mentioned in the options is sublimation. Okay, so next we will talk about sublimation. So sublimation, we know that it involves the direct conversion of solid into gaseous state on heating without passing through the liquid state. Okay, direct conversion of solid into gaseous without passing through liquid state. Process of sublimation is useful in purification of solids which sublime on heating and are associated with non-volatile impurities which don't sublime at all. Okay, so this is the catch here. So when is this method used? So it is useful in purification of solids which sublime, that is they undergo the change from solid to gas directly on heating, obviously, and are associated with non-volatile impurities. Okay, which don't sublime, obviously, which don't sublime because they are non-volatile. Okay, so we'll talk about it in detail. So let's first understand some examples, okay, of those solids which sublime on heating. So those are camphor, naphthalene, anthracene, benzoic acid, ammonium chloride. Okay, so these are some solids which sublime on heating. Okay, and to understand what's happening, so let's look at the diagram. So this is the diagram. So for example, here we have taken ammonium chloride. So let us say that we have taken a sample of ammonium chloride with some impurity which does not undergo sublimation. Okay, so and we are heating it. So what will happen? The ammonium chloride, since it undergoes sublimation, it will quickly become vapors, right? It will become vapors, right? And also this is an inverted glass funnel, and also we have closed it with cotton so that no gas can go through the glass funnel. Now, since the ammonium vapors are being formed, we can see there is clear temperature difference. Here the funnel will be very hot, here it will be cold, right? So the moment these vapors go and interact with the walls, what will happen? Because of the cold temperature, they will revert back to the solid state again. So you will find these vapors of ammonium chloride became solid, and they are in around these walls of the inverted funnel. And here we took, remember, a mixture of ammonium chloride and those impurities which are non-volatile. So those non-volatile guys will be left here, and ammonium chloride will be sticking on the surface of the walls of this funnel here. So that's how we can separate them. So that is the that is the catch for sublimation. Then we have the next separation technique which is mentioned to us, that is fractional distillation. Okay, fractional distillation. Okay, if the boiling point of two liquids, so let us say we have taken two liquids, and if their boiling points are very close to one another, let's say the difference is around 10 Kelvin. So they are very close to one another. Let's say we have again A and B, and A is 150 degrees Celsius and B is 160 degrees Celsius. Now here we cannot use simple distillation. We cannot use simple distillation. Okay, because at the boiling point of the more volatile liquid, this is more volatile liquid, this is more volatile, and this is less volatile. Okay, so at the boiling point of this more volatile liquid, there will be some amount of less volatile liquid as well, because their boiling point is very, very close to each other. Okay, so there will be some amount of B also. Okay, so therefore what we do is we carry out fractional distillation, and we do that by using a fractionating column. So I will show it to you in a diagram. The aim of the fractionating column is to, for example, you can see the fractionating column. This is the fractionating column. That's the only difference between simple distillation and fractional distillation, that there is a fractionating column. The aim of this column is to increase the cooling surface area. It provide surface, and it also provide hurdles to the ascending vapor and descending liquid. Okay, so I will write that down. That is really important, that it increases the cooling surface area and provide hurdles, or you can say obstructions, to ascending vapors and descending liquid. So we'll look into the diagram of fractional distillation. So in this diagram we have a fractionating column, and also there is rest of the apparatus is similar to simple distillation, but we have temperature gradient here. And by temperature gradient I mean, obviously since we are heating it, so this region will be the hottest, and as we go away from the burner, the temperature starts decreasing. Okay, that's a very important point. Or I can say in this point of the fractionating column, temperature highest, and at this point temperature lowest. Okay, so this is useful for us to understand the mechanism of fractional distillation. Okay, so obviously here we have taken a mixture of A and B, right? The boiling point of A was 150, remember, and B is 160. Okay, so A is obviously more volatile. Upon heating, since we are heating it, mixture will start boiling, and vapors will mostly consist of A and less of B, because A is more volatile, right? Because its boiling point is less. As these vapors, they travel up the fractionating column. Vapors of B condense more readily because temperature is still high here. So these vapors can easily condense. Okay. So vapors of B condense more readily than A. I will write down the point. Vapors of B condense more readily than A. Okay. Because temperature at which vapor B becomes a liquid again is 160 degrees Celsius, right? Because its boiling point is 160. So the temperature at which it will become a liquid back from gas will be 160 itself. So 160 is easier, or it is, it is possible at, this particular height of the fractionating column. For A to become liquid, we have to reach 150. So we have to travel up because temperature decreases. Remember, there is a gradient. So for A to become liquid, it will need to travel even more up the fractionating column as it becomes cooler. So therefore, vapors rising up, those vapors which are rising up, they will consist mainly of A. And since, if you remember, B, it became vapor, and since the temperature is high around here, it will condense and it will become liquid and it will flow down. So this will be richer in B, and these vapors will be consisting of A. So these vapors will be consisting of A, those who are going up, and the liquid that we get will be B. And these vapors, and we repeatedly do this process, and these vapors can escape into this condenser. Then we can cool down A and we'll ultimately get A. This is how we separate them. This is what the fractional distillation consists of. So the catch here is the difference between the boiling point should be less. For those guys, we can use this technique. And the last technique is steam distillation. Okay. So for steam distillation, I would have to give an example. So let us say I have phenol. And this is there in your NCRT, alcohols chapter. Dilute HNO3 and H2SO4. So nitration is going to happen. We will get orthonitrophenol and paranitrophenol. Okay. So these guys, ortho and para, they can be separated by steam distillation because the ortho isomer is steam volatile. Okay, I'll explain what is steam volatile. Due to chelation, it shows something called chelation. So chelation is, ring formation due to intramolecular hydrogen bonding. So there is intramolecular hydrogen bonding, so they form a kind of a ring. So that is known as chelation. Okay, the para isomer is not steam volatile. It is not steam volatile. Okay, that is because it undergoes association due to the formation of strong intermolecular hydrogen bonding. It shows intermolecular hydrogen bonding. Ortho shows intramolecular hydrogen bonding. The meaning of steam volatile is, steam volatile substances are those substances which can be converted into gaseous state just by passing steam through it. And obviously they will have lower BP than water because steam's boiling point, steam has a temperature of around 100 degrees Celsius, 100. So therefore their boiling point has to be lesser than that. Only then steam can convert them into gaseous state. Okay. So steam volatile substances which can be converted into gaseous state just by passing steam through it. Okay, and obviously their BP has to be lesser than water. Only then it will become only then it will turn into a gaseous state just by passing steam through it. So those substances which show this are known as steam volatile. Okay, so now we have two products that we have got. One is orthonitrophenol and one is paranitrophenol. So orthonitrophenol, if I show you the intramolecular hydrogen bonding, so it shows intramolecular hydrogen bonding, and para shows intermolecular hydrogen bonding. Okay, so this is what is known as chelation, and it is steam volatile because it is not associated with other ortho molecules. So therefore its boiling point is also lesser than 100 degrees Celsius. So therefore this is steam volatile. This guy, on the contrary, this guy shows intermolecular hydrogen bonding. It associates with other para nitrophenol molecules. So therefore, because of the association, its boiling point is more than 100 degrees Celsius. So that's why it is not steam volatile. So therefore, we can easily separate this mixture using steam distillation, because this guy is steam volatile, this guy is not. So this guy goes with the steam, and then we can condense those, and we can get this in the liquid state, and this remains in the test tube. Okay, now coming back to the question. In the question, they have given us a benzene ring first and bromine with catalyst FeBr3. So this is a typical case of electrophilic substitution. This is a Lewis acid. Okay, so we will get bromobenzene as our product. You can attach this bromine at any position of the benzene ring. Okay, then we have they have concentrated HNO3 and concentrated H2SO4. So obviously this is nitration. So we will get two products. So this is 2-nitrobromobenzene, or you can say this is the ortho one, and this is 4-nitrobromobenzene, or this is the para one, and this is the major product, obviously. And simple distillation cannot be the process with which we can separate them, because boiling point of 2-nitrobromobenzene or ortho one and the para-nitrobromobenzene, they are very close to each other, and to be precise, this is around 261 degrees Celsius and this is around 256 degrees Celsius, and you can see the ortho one has more because of more dipole moment. Okay, that's a different thing, but it is very near to each other. So therefore we cannot use simple distillation. If you remember, simple distillation is for those guys which have a huge difference in their boiling point. One of them can become a vapor, and then we can condense it and collect it in another test tube. Okay, so simple distillation used only when there is a huge difference in boiling point. Remember that. B, A cannot be the answer. B is sublimation. Sublimation also cannot be the answer, because if you want to use sublimation, at least one component should undergo sublimation. That is, it should undergo the solid to gas transition. Neither of them sublimes. So therefore B cannot be the answer. And coming to option D, D option is steam distillation. For steam distillation, one has to show intra and the other has to show intermolecular hydrogen bonding. So here it is not possible, because bromine does not form hydrogen bond with, there is no hydrogen atom which is connected to, a very electronegative atom like nitrogen, oxygen or fluorine. So here there is no scope for hydrogen bonding at all. So therefore even you cannot use D. Steam distillation is to be used when one shows intra hydrogen bonding, other shows inter hydrogen bonding. And the C option is fractional distillation. That will be the answer, because if you remember, those guys which have very small difference in their boiling point, they are separated using fractional distillation, where we have a fractionating column. Okay, and the more volatile guy, it rises up, and we are left with the less volatile guy, and we separate it. Okay, so therefore C, or the fractional distillation, will be the answer. Okay, so the answer is C, fractional distillation. Okay, thank you.